Hello everyone, this is the instructional video for our first optimization exercise. And what I'm really going to do is just walk you through the process of doing the first exercise. There are two parts of it. The first part is basically doing the exercise as it stands with the given constraints. And then what I would like you to do is I would like you to change the constraints and see what numbers you get. You will turn in two files. One of them will be a copy of the very file that you're looking at. You'll call it butterguns1, and that's the first scenario. And the second file will be something that is slightly different, slightly modified. You'll call it butterguns2, and you'll turn both of them in as this week's weekly assignment. So what do we have here? I have given you a copy of this sheet, but I will take all of the numbers and all of the interesting information out of it. It will just be blank. What we have are different parts of our optimization exercise, and there are three different categories of cells in our optimization exercise. The first one is our objective. And the objective in this particular case, in this particular scenario, is for our character in our story, whose name is Hans, who is currently serving as an undercover agent or covert agent behind enemy lines. We want him to maximize his revenues. And why we want him to maximize his revenues is because his revenues are what drive his ability to do more production in the periods that follow. So we want to make sure that he's able to produce enough product that his revenue is maximized. And that's where our optimization problem comes in. So the revenue is our objective. And that's a commonly accepted term, the word objective, for what it is you're maximizing in a maximization problem or an optimization problem. The next thing that is a common occurrence in an optimization problem are the cells that you're changing. These are cells that have been connected to other values that ultimately will derive the revenue, the objective, but they're the cells that get changed. And so in this particular case, we are looking at the number of guns or the number of tons of butter that Hans can produce in order to maximize his revenues. Currently, I've just thrown a 1 in there, 1 gun and 1 ton of butter, and you'll see that that's not a very maximized amount. But that's just a placeholder for now. The last thing, or the third thing that drives an optimization problem are things called constraints. And these constraints are basically what are your limits to what you're able to do in your optimization problem. You're only going to be able to optimize your objectives so far because it's going to be held back by certain limitations that are placed upon the actual problem itself. Here are those limitations. So the first part is storage. Storage. Each gun takes a half meter of space, or half cubic meter of space, and each ton of butter takes 1.5 cubic meters of space. That's interesting to know because the overall storage limit that we have is 21 cubic meters of space. So we cannot exceed 21 cubic meters of space. And currently, because we have 1 gun, which takes a half, and 1 ton of butter, which takes 1.5, we are currently using 2 cubic meters of space. The other thing that is a constraint or limitation on our optimization problem is price. So the price of every gun is $150. That is the price to produce the gun itself. That's what it costs Hans to produce it. The price for producing a ton of butter is $100. And so that's what it costs him to produce a single ton of butter. Well, we know that he has only $1,800, and he has to make that $1,800 go as far as possible. So does he spend more money on guns, or does he spend more money on producing butter? Which one is going to return him the greatest amount? The last thing we have down here is revenue. Revenue is what he's able to sell these products for. So he spends $150 to produce a gun, but he sells it for $195, which is a $45 profit. The other thing he can do is he can create a ton of butter at $100. He can sell that at $150 for a $50 profit. Okay. Now remember the premise of the story is that we're trying to figure out the best possible combination of guns and butter. There are a couple rules that we have to follow. First of all, remember Hans is in country, undercover, as a covert agent, so he has to produce some amount of butter in order to be able to keep up his guise, to keep up his disguise. So butter cannot be 0. We cannot have a negative amount of butter, or a 0 amount of butter. He can't just produce guns. Also, we want to try to see if he can produce as many guns as possible, because that's really the reason why he's there. He's going to produce just enough butter in order to make it look like he's a farmer, but still, he's got his side business, and that's really why he's there. So these are all set up. We got our objective, we got our changing cells, the cells that will change, and you'll see that these values down here, they're not going to change, except for these two will change as these change. right? So now we're going to take a look. Right now we have, again, we have one gun and one butter. We see that we're using up 2 cubic meters of space, and we've produced costs of $250, which means we've eaten into our $1,800 that we started off with. Okay, well, let's go with 2, because we have quite a bit of room left. So we'll go with 2 guns and 2 tons of butter. Okay. Now we've used up 500 of our $1,800, and we've used up 4 cubic yards, or cubic meters of our 21 cubic meters. So we can keep adjusting these numbers off and on, and coming up with different combinations to try to get as close as we can to spending the entire 1,800, using up all of the 21 cubic meters of space, and thereby hopefully maxing out the amount of revenue, which was our initial objective to begin with. This is where Solver comes in. So we can go to our revenue, which is our objective, and we can say, let's bring Solver up. Now, I have got Solver already ready for you. I'll let you set this up on your own when you get your own file. Okay, remember one of the first things we talked about was the objective, and the objective is here. It is B1, $B, $1, which means it's an absolute reference to cell B1. And there it is. That is what we are optimizing, or what we are maximizing, what we're solving for. What we want to do is we want to make this the maximum value. So we'll check the box, or check that box, to ensure that we're trying to get to the maximum value. And we're going to try to make that the maximum value by going to our second piece, which is our changing cells. And the changing cells are these 2 cells right here. It's B4 and C4. Okay. So far we've said we're going to change B4 and C4 in a maximum way to be able to sort of maximize what's in B1. But we have constraints. Remember, we have constraints that we have to deal with. Here are the constraints that are built in right now. We say that B4, C4, those are the cells right here, they have to be integers. And what we're doing is we're assuming that we cannot produce part of a gun or part of a ton of butter. We have to produce in whole units. So we make those set to an integer. That's constraint number 1. Constraint number 2 has to do with our space. Remember, we only have 21 cubic meters of space. So we have to make sure that whatever we use is equal to or less than the 21 cubic meters of space, and that is your second constraint. You're saying that what's in cell E7 must be less than or equal to what's in cell D7. The same thing goes with the costs, or the prices. We only have $1,800 that we can spend. So we have to make sure that whatever we spend in cell E8, let's go to the next one here. There we are. In cell E8, we have to make sure that whatever we spend is less than or equal to what's in cell D8. So those are our 3 constraints. So we can go ahead and run this now. There's a couple of things we want to check. First of all, go ahead and check this box. It makes unconstrained variables non-negative. I don't think there really are any unconstrained variables that would maybe slip into being negative, but in some solver applications there can be, so we'll just check it to be safe. And there are multiple different ways that we can actually run this. We can run with either a nonlinear, a simplex, or an evolutionary. They recommend, in this particular case, we recommend using the simplex LP. It's the simplest one. So we can go ahead and go solve. I've got to get to the right spot. That's what I want to solve for. Okay, and it brings up a solution. Okay, I had to adjust some stuff, so I tucked out for a little bit, but I'm back here. So I've run Solver, and it's brought up our solution. All right, what do we have here? We have our maximum revenue is $2,580. We can produce 4 guns. We can produce 12 tons of butter. And when we do that, we're going to use up 21 of our cubic meters of space, but we're going to use up all $1,800. Well, that's fine. We're only producing 4 guns. That's a little disappointing. We're producing a whole lot of butter, which is 12 tons of butter. So what if we decided that we wanted to make one slight adjustment to this, and we wanted to say, guns, let's see if we can't get more guns. Let's see if we can get 6 guns. So we'll make guns at least 6. That means we're going to cut into our butter tons, but let's see what happens if we make that adjustment. So we'll go back to Solver, Data, Solver, and I'm going to add another constraint. I didn't show you how these constraints were put in, but by doing this, I can show you how we actually add each of these constraints. So I'm going to click on Add, and I'm going to say that the cell reference that I want, which is going to be this cell right here, B4, should be equal to or greater than or equal to, and I want the constant to be 6. I'm going to go ahead and add that in. Okay, on this, oops. We're done with that. Okay, now we have it there. B4 has got to be greater than or equal to 6. We're still trying to make these integers. We're still saying we have these constraints of space and cost. So we'll go ahead and solve again for this. All right. We dropped a little bit on our revenue, but our number of guns is up. Our tons of butter is down a bit. We've used up all 1,800 of our dollars, but we're only using we're using now a smaller portion of our storage space. Well, that's still maybe a better solution than having only 4 guns. But what I would like you to do is I'd like you to go through and take the empty spreadsheet that I'm going to give you. I will have you set up with the objective, with the changing cells. I'll have you set up with the limitations, the constraints that are built in here. What I want you to do is go through the process of setting up Solver and actually running through Solver. When you do that, go ahead and save that off to a file called butterguns1, and that'll be the first thing you turn in. The next thing you turn in, I'm not going to show you on this video. I think you can figure it out from the information that I provided you in the assignment. You're going to make a couple of changes to the limits, and you're going to make a couple of changes to the price. And then you're going to resolve for that. And you'll turn that in as butterguns2. If you have any questions, let me know.